All right, howdy. So let's see what we've got today. Today we're going to talk about work and energy. First, we should talk about work. Work is something that uh, relates to force. Basically, it's how much the force actually does to the object. So that the total work done to an object, and that's how we think about it in physics, is we're looking at what happens to objects, not the things that are doing it in general. Um, so the total work done to an object in a process, it's going to be in a mechanical process that goes over some distance, is the net force the resultant force, the leftover force from the sum of all the forces applied over the distance. Okay, and so that means something like the total work is equal to the net force times the distance. And we're going to talk about how this relates to energy in just a second. This is the definition we'll use. Um, it's important here to remember that work now is a technical term. It's what we call it in physics. So this can cause a little bit of a disconnect, of a dissonance in your interpretation of things when you read about work and so forth. But in this case, all we mean is how much force is applied over a distance. And this amount of work is what's going to result in an energy change or a velocity change or something like that. If there's no net work done on an object, then there's not going to be any change in its speed, right? And there's not going to be any change in its energy. So that's what we're going to mean by the work, is how much you change the energy. Okay, and the work done by an object or by an object on another is the force applied by that object on our object of interest times the distance. And I ran out of room. And it looks like by an object, the process is the net, the force, the distance. Okay, so what this means is that if we have our work done, it's just the net force over the distance. Okay, so it's that residual force that's going to cause acceleration. And so that's going to be the sum of all of the other forces. So some of these will cancel parts of other ones, and at some point you're going to end up with some resultant from this sum, which is not going to be any one of these. I mean, technically it could be all of the others balance out, but usually no subset of the forces balances out unless they all balance out. Although sometimes they do. But the total work, W here, is made up of these constituent works, one for each one of these forces. So if we have one force N, the last force, is going to create a work N. And the first force, F1, is going to create a work W1. And each one of those is just the force applied by the same force for each one of these different objects. So, for example, if we have our boat here, there's a force coming this way for the propeller, right? And there's some water resistance coming backwards, and you get a net force. All right? If you remember that. That means that this work here is associated with that. But there's some work done by the propeller that makes you go, right? And that's one of these ones. And there's some work done by the resistance that keeps you from going any faster, all right? And the distance is going to be the same because the boat, when it's traveling, right, like that, is going to go the same distance, should be center to center, same distance no matter which one of these things it is. Hopefully your propeller goes the entire distance with you, right? So that same distance is going to apply. So the D's are all the same, but the forces are all different. Okay, so that is sort of the idea about the work, and that's how we think about the work in physics. Okay. Again, this is the work that's going to cause changes in motion. This is going to be very important. So maybe in class I'll talk a little bit about an engine or something, about the work done with an engine. And even if you're going at a constant speed, the engine's still doing work, right? You're still using gas, you're still using fuel. As long as you're using the fuel, this is important, right? Because this is right? The force from the propeller, even if it's being counteracted by the force from the water resistance, and you do no work, you do no net work or total work, right? You don't change your speed, you don't have any acceleration. That's still using up your gas, and that's still important, right? So we'll talk a little bit about that in class, I guess, just qualitatively. But this is what we're going to do for the problems and stuff right now, is look at these issues. Bye now.